into our last lesson for the day. In fact, this is usually a section that if you're in regular geometry, you kind of skip through this. But because you guys are going into Algebra 2 Honors next year and not regular Algebra 2, Algebra 2 Honors is called Honors because it's not only Algebra 2, but it's Algebra 2 and Trig. So I figured in going through this will hopefully better prepare you for Algebra 2 Trig next year. One thing that's kind of cool about Algebra 2 is you really figure out how to do everything. So far we've looked at how to find angles and sides with any triangle as long as it's a right triangle. Well, law of sines was created for triangles that are not right triangles. So law of sines is only going to be used on triangles that are not right triangles. And this theorem will allow you to find the side or the angle measurement of any triangle, okay? One of the number one misconceptions, because the book sets it up like this, is that students think that they have to write 3 fractions to solve it. You're only going to be setting up 2 at a time, okay? So what the idea is that you have an angle, for example, capital A, right? And the corresponding side that goes with capital A is the side across from it, lowercase a. We've seen this comparison for quite a few days now, right? And you'll notice again that I have, let's say I'm looking at angle B up here. Angle B corresponds to the opposite side, which is lowercase b, and so on and so forth for C. So let's go ahead and see how we can use this formula to be able to find solutions. So what I have here is I have a triangle with a couple of pieces of information. It is not a right triangle, so I can't use any of the theorems that I've learned up to this point. That's why I'm using sines and law of sines for this question, okay? So I'm going to start with what's given. I notice that I have the number 15 here, and I also have the 35. And I know these two are related because they're directly across from each other, right? So I'm going to start by writing my proportion with that 2 pieces of information. So sine of 35 directly relates to the side, which is 15. Now I'm going to go ahead and pick another side and angle. It wouldn't be smart to pick the t's because I don't have any numbers for either of those. So when I set these up, I need to only have one variable. So if I look at my s here, I do have 38, and then I have a letter s. So that's going to look like sine of 38 degrees divided by s. Now, because these are set up similar to proportions, we can always solve these by cross multiplying. So here's what I have. When I cross multiply, I have s times sine of 35 degrees. Then I have 15 times sine of 38 degrees. And I want to get my s all by itself, so then I'm going to divide both sides by 35 degrees. And basically your math on these is going to be the same almost each and every time almost, okay? So that's going to go away. And now I'm going to need my calculator, and you'll notice the instructions say to round to the nearest tenth. Let's see if I can even remember this whenever I go to plug it in. So let's see. Pull up my calculator. Oh, I don't want to do that yet. Okay, 15 times sine of 38 over sine of 35. 15, there we go. It's going to keep it up for me. All right, here's my calculator. Again, always verify that the top right-hand corner has that Celsius symbol, okay? You'll get something completely different if you don't. And I just kind of like to plug in everything little by little. So for me, I like to do sine of 30 degrees first. And I'm going to hit enter. And then I'm going to multiply that by 15. So this is my solution so far for just the numerator. 9.234, blah, blah, blah. Okay. Then I'm going to divide that by the sine of 35 degrees. And there you go. I have my answer. So looks like it was 16 points to the nearest tenth. So 16.1 degrees. And that was my solution for S. Okay. Now let's go ahead and I think we were supposed to find all the unknown measures. So let's clean up my work a little bit here. So S is 16.1 degrees. And I'll even put it on here. Oh, wait, it's not degrees. Sorry. It's a side, so it can't be degrees. All right. Now, how do I use T, or how do I even start with T? Well, in order to find T, I need to find one of these guys because I can't have two variables. So what other information can I use to find either a lowercase t or an uppercase t? Well, usually on a triangle, I know that any triangle, all the angles add up to 180, right, you guys? So angle T I can find by adding all of the angles inside the triangle and setting them equal to 180 degrees, right? So let's go ahead and combine those by adding 35 plus 38. And I'm going to get 73. Oops, plus equals 180 degrees. Okay. Then I'm going to go ahead and subtract 73 from 180, and I'm going to get that angle T equals 107. And angle T, it's a capital, so it is going to be degrees here. So now I have found two pieces of the missing variables. I have one more letter left, which is lowercase t. So when I'm solving these, I always like to start with the original of what's given. I don't like to use like any of these items that I found along the way because those are, maybe I made a little mistake and now I'm going to get two parts wrong instead of one. But also like 16.1 was rounded, right? I want to use the best numbers possible. So when I'm looking at my ratio that I'm going to set up, I'm going to use this 35-degree angle and the 15. I really don't like the colors that I'm having here. Here we go. Let me try to set it up here out to the side. I'm going to have the same proportion, sine of 35 degrees over 15. And my goal is to find lowercase t. So in order to find lowercase t, I need to compare that to capital T, which I found to be 107 degrees. So I'm going to put that on top. Now, when you have any of these proportions, you're always going to have the same type of solving steps. So the first thing you'll do is you'll cross multiply. And then you're going to go ahead and divide. And what's important to remember is sometimes you are going to have to use this where your variable is an angle. So make sure you understand that if you like had sine of t, for example, that you're using the arc sign, right? Keep that in mind. That was a review question. Here we go. I can show you how to pull this up again. So it looks like we're going to do 15 times sine of 107. And you guys could totally just type it in from left to right if you want. But for me, I just always like to have my work written out as if I were actually solving the problem on pencil and paper. I have sine of 107 times 15. I don't know. Part of me doesn't really trust the calculator with order of operations. I don't know. Some calculators actually don't do order of operations. This one does, but I just like to go ahead and be safe by plugging it in little by little. All right, and it looks like rounded to the nearest tenth, we're going to have 25.0. Again, lowercase letters are sides, uppercase letters are angles, so I don't need to put a degree on this question. Okay, so I tried to solve every piece of this triangle. You guys are going to try it the same in the next example, so do your best that you can, and if you're unsure or not clear on how to do it, make sure you add it into the collaborate section We'll definitely go over more examples of this tomorrow in our Zoom session. And I think you only have a couple of problems to try out. Definitely have your calculator ready so that I can help you with that. Okay, guys? Have a good day.